Hi, I'm Jessica. And I'm Becca. And we're doing Chapter 17, which is Reaction Kinetics. Okay, so kinetics are the study of reaction rates.
The reaction mechanism is the steps by which a reaction takes place.
And the collision theory states that molecules and atoms must touch each other properly and hit hard enough before
Hi,
they can
I'm
react.
Jessica.
And I'm Becca. And we're doing Chapter 17, which is Reaction Kinetics.
Okay, so we're going to show you a little bit of how the collision theory works. And this first reaction will be when the two particles are not moving hard enough or fast enough, so they just kind of lightly hit each other. So we'll show you. Okay, so see how slowly we're moving, and we just kind of like move off, and it doesn't work. Okay. And this next one of the particles is going like totally sideways, so they don't hit right. So I'm going like this, and like we're going fast enough, but it doesn't work. And this last one will be just right because we're going at the perfect speed, and we're going like hard enough too. Okay, so and that means that the reaction occurred. And that is our explanation of the collision theory.
So these are the 5 factors that affect rate.
The first one is the surface area. The surface area affects the rate because smaller particles have a bigger surface area, so they react faster.
Then there's the nature of reactants, and the rate depends on a particular reactant and the bonds involved.
The next one is temperature. When there is a higher temperature, the particles move faster, so there is a greater kinetic energy and stronger collisions, resulting in a faster reaction.
After that is concentration, which means more concentrated means the molecules are closer together, so they collide more often and have faster reactions.
The last one is catalysts, a chemical that makes a reaction faster by lowering the activation energy without being used up.
Okay, now I'm going to show you one way to find the rate law. And we're going to find the rate law of just an example reaction of where A plus B yields C. And A plus B are the reactants, and C is the product. And at the end, your rate law is going to look like this, where R is the reaction rate, K is your constant, and we can find the constant at the end. And these brackets around A and B just mean the concentration. And then this little X and this little Y will be like how much of it you have. Okay, and then these are the numbers that they'll give you. And what you're going to do is first you want to find, well, you can find like how much is in, they're going to be in moles. See, little m's. And the rate is in moles per second. And if you want to find, well, let's look for B first, okay? Okay. When you find B, you have to use A. And A has to stay the same. So here it's 8 and 8. So we're going to circle that. And we're going to look at these 2 rows only. So what we want to do is, since these 2 are the same for A, we're going to use these 2 rows. And B, we're looking at from, let's say, step 1 to row 1, 2, and 3. Okay, so from 0.06 to 0.03, you divide by 2. So we have to remember this number, because that's going to help to find the concentration. So now we also have to look at row 1 and 2 of the rate. From 0.012 to 0.006, sorry, is also dividing by 2. And because 2 equals 2, and that's basically 2 to the first power. So the concentration of B over here would also equal 1. Now, if you want to find the concentration of A, you have to look at column B and see which of these 2 numbers are the same. And there's here and here. So we're going to use row 1 and row 3. Yeah, these problems, if you are doing this like circling thing, they're going to get a little bit messy, but once you get the hang of it, you won't need to do all the circling. Okay, so when B stays the same, we're just going to ignore it because now we're looking at column A. A is 0.08 and it goes down to 0.04. That is also a dividing by 2. So we'll save that here. But from here, 0.012 to 0.03, that is divided by 4. So we're going to put 4 here. Now here you can see, oops, we don't need that here, 2 to the first power equals 2. But here, 2 to the first power doesn't equal 4. 2 to the second power equals 4. So you're going to take that number and put that as the concentration of A. So this is the answer, is your rate law.
Okay, I'm about to do the same problem, but a different way. So what I'm going to do is I'm going to write out this equation. R1 equals K times the concentration of A and the concentration of B all over R2 equals K to the concentration of A and the concentration of B. And so, when you're trying to find the concentration of A, you look at which one in column B is the same. So that would be this one, which is 1, and this one, which is 3. So, now, for R1, we wouldn't plug in the R for row 1, which is 0.012 equals K of concentration A, which would be 0.08 times the concentration of B, which is 0.06, all over R of 2, which is 0.003, equals K of concentration A, which is 0.04, times the concentration of B, which is 0.06. So, now what you're going to do is you're going to cancel out what's on top and what's on bottom, which is the 0.06 and the 0.06, the K and the K. So, using your calculator, what's 0.012 divided by 0.003? It's 4. Equals 0.08 divided by 0.04, which is 2. Now, 2 times what power equals 4? That's 2. So your answer for concentration A is 2. Okay, so now you're going to find the concentration for B. So what you're going to do is you're going to look at what's the same in column A, for column A, which is the first one and the second one. So now you're going to fill in for these equations. So R1 is 0.012 equals K of concentration A, which is 0.08, times the concentration of B, which is 0.06, all over R2, which is 0.006, equals K times the concentration of A, which is 0.08, times the concentration of B, which is 0.03. Cancel out everything on top and bottom. which is the K, 0.08, and the 0.08. So now, what's 0.012 divided by 0.006? That's 2. Equals, what's 0.06 divided by 0.03? That's 2 also. So, 2 to what power equals 2? 1. So your answer is 1. So now your equation is R equals K times the concentration of A to the second power times the concentration of B to the first power. And you're done.
Thanks for watching. We hope you learned a lot.